Alright, so in this video, what we're going to take a look at is we're still going to review everything we've talked about so far. So this is our third video. We're still going to review the whole idea of parent function and transformations and being able to pick out what the equation would be. But at the same time, we're also going to talk about vertical stretch and vertical shrink and how we can identify that and to correlate it to what we're looking for. So this is a little more. This is like, if you're doing this one and it's making your brain hurt a little bit, it's because this is requires a little bit more higher order thinking. So remember, our parent function for this video is the absolute value. Okay, so this is the guy we're looking to right here. So if we made a table of values for the absolute value, so let's use our calculator to do this. So let's go to y equals. Let's clear out what we had. Okay, now the absolute value is kind of hidden. So to find the absolute value button on your calculator, you go to Math. You go over to Num, and you can see number 1. Pen number 1. Okay, so you can see now that pulls up. Now, if you have a TI-83, it'll just say ABS, but with the TI-84, actually will give you the actual bars, like absolute value. So we just want the parent function, so we're just going to hit the bars, and so you can kind of see that you got the right thing, arrow out over there. All right, let's go ahead and graph it so you can see what you got. Okay, remember, at any time, I'm not writing a lot of stuff down right here because I'm assuming that since this is a video, if you need to, you can hit pause, rewind it a little bit, rewatch a part, write down the code, the commands as you're going, so you can have it as a reference in the future. So here's my parent function. What I want to really look at is I want to look at the table. So you notice the table right here is in blue right above the graph key. So I want to look at like a table of values. So I go second, because it's blue, and graph. So instead of getting the graph key this time, I actually got the table key. And what I want to show you here from this is I want to show you that this is like a table of values that you create when you were little. So like when you were in middle school maybe or high school, and your teacher said create a table of values that you can graph. So what we have right here is if I made an XY table, and I said, okay, well, I'm just going to take a few numbers. I said, okay, I'm going to plug in -4. I would get out +4. If I plugged in -2, I get out +2. If I plugged in 0, I would get out 0, +2, 2, +4, 4. You can see that as I go down where I got those other numbers. So this is my parent function, and this is how I will identify, for this particular case, like a vertical stretch or shrink. Because what I'm going to be looking at here is that if I had a vertical stretch, and let's just say that I gave you the equation of y equals 2 absolute value of x. Well, that means that my a value is greater than 1, so I have a vertical stretch. Well, what that means, if I come here and I put that guy in, I say 2 math num number 1 x. So now I'm going to have side by side, so I can hit graph, and I can see the difference between the two. So I can see that that graph grows more quickly. It's a vertical stretch from the parent function. If I go to my table, then what I have is I can see my side by side. I can see my parent function, and I can see my y values are twice as big. So that's what a vertical stretch means, is that the values are twice as big, that you created something that's a little bit larger. So we're going to use this concept to be able to find out when we have vertical stretch and vertical shrinks. So in this case here, if I plugged in, we'll just go with -2. Well, no, we'll do the same numbers. -4, I get +8. -2, I get +4. 0 is still 0. 2, I get 4. And 4, I get 8. So you can see that everything is twice as big. And just for the sake of conversations, if I shrunk, so if I did a shrink real quick, and I did y equals, let's do 1/3 of x, so y. Okay, so remember the fraction key on here would be alpha, y equals number 1, so I could do 1/3. I'm going to get rid of that 2. Okay, remember, I'm assuming that you'll hit pause and go back and watch those keystrokes and write them down and practice yourself, so I'm not writing them down. If you want to hit the graph to see what it visually looks like, there's the parent. That is the shrink. So a shrink is like taking it and smashing it down. A stretch is like grabbing it and pulling it up. So now I go to the table to compare my values. And what we're going to see here is that when we create this table of values, that at -4, I get 4 over 3, which means I took that original value and divide it by 3. I take -2, and I get 2 over 3, which means I take the original value and divide it into 3 parts. 0 is still the same, so +2 will be the same as, my pen just ran out again, I didn't charge it. +2 will be, and I'll just use right here, we just talk about it. +2 will be 2/3, and +4 will be 4/3, so same deal. Okay, so just kind of being able to compare. All right, so now let's take a look and see if we can identify the transformations of our particular graphs. So on our first graph right here, from the parent function, I'm hoping what you're seeing is that vertex, this location right here, has been shifted down 2 times. So the other thing to kind of check would be is does it look like it's been vertically stretched or shrunk? And we're going to say no. We're going to say no shrinking on this guy. So this guy, vertical shift, so y is equal to the absolute value of x. Vertical shift is on the end, down 2. Okay, this guy from the parent function looks like he's flipped over the x-axis. So we go back and think about to ourselves and say, okay, we just learned that if you flip something over the x-axis, then you put your negative on the outside. So we come back and we say, okay, well, this will be y is equal to a negative absolute value of x. Okay, we got a couple more examples down here. And you might want to hit pause at this point and say to yourself, okay, I'm going to try to figure this one out on my own. And that's completely okay. You should do that. Well, this guy, look at the vertex and it hasn't moved. So it's not a horizontal, it's not a vertical shift, so it's got to be a stretch or a shrink. So if we made a table of values real quick to identify what that would be so we could compare to the parent, and we say let's take -2. So at -2 we're at +4. At -1 we're at +2. And you know what? Let me back up there. Let me use the values that we use on our table to have some direct correlation between the two so you can see it all the way. Let's do -4. So at -4, I'm up +8. At -2, I'm at +4. At 0, I'm at 0. At 2, I'm at 4. At 4, I'm at 8. Well, this happens to be the example that we did, isn't it? So this is actually going to be y is equal to 2 absolute value of x, because I can see that from the parent to this guy, I'm twice as big. All right, the next one, we go through the same process. We say, okay, well, our vertex, there, it hasn't moved. So there's no side-to-side horizontal. There's no vertical. So it's got to be maybe a vertical stretch or vertical shrink. So let's take a look at the table of values. We'll use our same values, so -4. At -4, I'm +4. At -2, I'm +2. At 0, I'm 0. At 2, I'm 2. At 4, I'm 4. Wait a second. That's the parent function right there. That is the parent. That is y is equal to the absolute value of x. Okay, last one. Great example because it has a transformation. So we look at the vertex. Remember, the vertex would have started at the origin. So remember, hit pause and do it on your own if you want to try it, and then come back and finish watching and compare answers. So in this case here, we've moved 2 times to the left. So we say to ourselves, okay, where does the to the left come into play? And so we start thinking about our transformations, and we say to ourselves, okay, well, to the left comes into play inside the absolute values. So I actually move to the left, it's not going to be minus 2, it's going to be plus 2. And then we also can see that we went down 1, 2, 3. So our vertical shifts go on the end, so that would be minus 3. All right, so take a look at that, see what you think. Hit rewind, practice. Go in and practice in your homework and see how this correlates to what you're doing in there. And let me know if there's any questions.